Good evening, everybody. Good to have everybody here. Today we'll just right off the back of where we stopped in our last class. Um, so yeah, just hold just a second while I present. Yeah, can you all? Oh, hold on. I didn't even make an effort to share. Okay, share screen. Can you all see my screen?
Oh, yes.
Right. All right.
You're sharing the whole of your screen, yes?
Okay. Yes. That is actually intended. All right. So, cool stuff. Right. So, like I said, in our last class, I don't know those of you who were here, we had done the fundamentals of backend engineering. We had learned basically the pieces that you need, all right, to do effective work as a backend engineer or to even make sense of the entire backend process. All right. So today we'll be looking at another crucial piece as it pertains to backend engineering or backend development. All right. So we'll be looking at databases today. We'll be discussing, I won't say intensely, but I mean, you should know just enough to give you the perspective as to how it fits into the backend engineering process, right? So that's what we'll be looking at today, all right? So we're looking at database management fundamentals, right? So these are the learning objectives. You should understand database management or database fundamentals. You should have a basic feel for database schema design. You should understand the basic principles of RESTful APIs. All right. So kicking off, I like to start my sessions with an analogy. Okay. So how I like to describe a database is like a digital filing cabinet. All right. So you think of it like a filing cabinet. I don't know if I'm sure most of you have it as tools in your houses. All right. So you have things stored in there in those cabinets. All right. So a database is like that. It's just that this time you store data in there. You store data in the filing cabinet. All right. And then you have a table, right? Each table is like a spreadsheet. I don't know how many of you have used spreadsheets before. I like to think that almost all of us have at least come across a spreadsheet. So a spreadsheet is just basically a table that has rows and columns, and every entry in a table, right, is referred to as a row, right, and then every column, right, refers to an attribute. Okay. Now, a database is what houses these tables. Okay. So that's the basic introduction to databases. Okay. You would see more of it as we proceed. Okay. Now, this is actually gotten from our last. So this is um, a server. A server is a computer with networking capabilities and ability to store and process data. Now, we had discussed about this in our last class. So we learned that a server is just a computer with networking capabilities. So if you have a computer, all right, that has a network card and an adapter that allows for sharing data between two computers, then that computer can be regarded as a server. Okay. Now, why is this important? It's important because data lives on the server. So databases actually are situated on the server. They actually live on servers. They don't live on the fly. They don't live on the cloud. You know, back in the day when they say when they say cloud, you're doing cloud computing, we used to think that, oh, maybe they were magic computers that used to live on the cloud. But what they mean in essence is a computer that is just remote, a computer that is far away, a computer that you cannot see or touch, but then you can utilize the properties that it carries. So a server basically is just a computer with networking capabilities so that if the computer is in London and I'm here in Nigeria, I can still use that computer. So again, back to databases, because that's the subject of focus for today's class. Database actually lives on a server. So also in our last class, I had shown you all um, how you can run an application on your local machine. Okay, so you can spin up a Node.js process, a Node.js backend server on your local machine. You can spin it up. You can spin up a MySQL database on your local machine. All of those, right, have IP addresses, right? So a database too, yes, you can spin it up on your local machine, and of course, it would also have an IP address. But the point is, um, e- databases live on servers, and on these servers, each of the servers have a unique IP address that allows for connection to it. So, like your machine, that's a local. Of the word local just mean is actually a term in when addressing servers. It doesn't mean that your computer is local. Don't take it in literal sense. All right. But local just means it's local to you. It is your computer. You are accessing the resources that lives on that machine. All right. Now, your computer can be regarded as a remote machine or can be regarded as the cloud, all right, depending on where you're connecting from or who is connecting to it. So if my computer is here and I want to spin it up as a server and have you connect to it, on your end, when you're connecting to my server, you would regard my computer as a cloud, all right, as the database that lives in the cloud, right? So I just wanted to clear that misconception for those of you that still carry it. All right. So long and short is a database lives on the server, right? Now, a database is an organized and persistent collection of data, of structured data stored electronically in a computer system. It's designed to efficiently manage, retrieve, update, and delete information through a database management system. Now, this is just the textbook definition of what database, but the part I really want to state is manage, retrieve, update, and delete information. Now, if you pay attention closely to how you use computers or how you use software applications or how you use basically softwares, all right, most of the things you do center around retrieving, updating, deleting, and management. It centers around these four lines: manage, retrieve, update, and delete. Okay, so if you are on Facebook, for instance, you're scrolling your news feed. What are you saying? What are you doing? You are retrieving data. Okay, so when you go on Facebook, I like to think that there's a request made to the data Facebook's server that retrieves all of the relevant information you want to see. And so it retrieves that and sends it back to you. Now that's a process in itself. That's something that you are doing behind the scenes without knowing. Okay. And then updating, say for instance, you make a post, okay, and then 20 minutes after you don't like the phrasing of it may be a sentence in the post, or you don't like the fact that you didn't put a full stop or you didn't put a comma where it was supposed to be, and you can update that, you can edit that post. Okay. All right. So that's updating. Okay. And then let's say the post few days later, you're not feeling it anymore. The post maybe it doesn't have the reactions that you want. You can delete it. Okay. You can say, I don't want you again. And so you delete it. And now by deleting, what happens is that where that record was stored in the database, you're just basically saying, look, I don't want you there again. Just get out. So You get, so that's what databases, that's the idea behind it. Okay. Databases allow for management of records, okay, on the system. And most applications, right, in today's world, they have databases behind them. They have databases backing them up. I mean, I don't want to go into much detail, but even if you are building a web app, a simple web app, all right, anything that requires persistent storage of data, and by persistent, I mean data that you can, even if you shut, in very simple terms, if you put off your data and put it back on, it would still be there, all right? Um, you still need databases. Okay, so even on your browser, there are mini databases. There's local storage for the guys who are front end, who have an experience with front end. I don't know. I think in your front end sessions, you must have heard of this local storage in your cookies, in your cache, many places. All those, there are databases there that allow for persistent data storage, and all of them follow the same principles: manage, retrieve, update, and delete. Right? Is that clear to everybody? Is that clear to everybody?
Yes, yes.
Right. Okay. So did now I did this just to give everybody a visual picture of how things work. All right. So again, a server is what houses the database. All right. So you have a server, a computer in this case, that has a database living in it. Okay. And in this database, what can you find? You find tables. Okay. And now in the tables, what do you find? Rows. Okay. So rows live in tables, and tables in databases, and databases in servers. Okay. So that's just the flow. Okay, and we'll see all of these very soon. Okay, so the project time now, I very quickly I want to show you how you would create a database using MySQL, and we would create a database on MySQL. We'll create a database and would also create a table. Okay, so moving on, let me open my terminal, and so for I carefully chose this. I chose to use my terminal and not a visual tool like MySQL Workbench and or DBeaver. That's how they call it. I mean, I started using that one recently, but the reason why I'm choosing my terminal is because most of the time, as a backend dev, you would be here, all right? I don't know. These days, I find it odd when I see developers, backend developers, for instance, who don't use Linux or who are not familiar with this, because most of your life is centered around here. All right, is you are either on a Linux server trying to manage configurations or trying to fix one or two things up. So just being able to play around with this would make you very, very proficient. So that's why I'm choosing this. But of course, there are tools out there. There are tools that can make this process a lot smooth. All right. So again, just to buttress the fact that to further illustrate what I said, that a database lives on a server. This is a server, all right? This the terminal, all right, for those of you who don't know, is just an environment that allows you give commands to the computer. Okay, so as it stands, I have my SQL installed on my machine. All right, and my SQL is the database engine. All right, where this is the database engine that I'm using to run the database, or that I'm using for my database. Of course, there are many other ones. There's Postgres. That's a relational database as well. There's MySQL, like I said. There's MariaDB. There's my Microsoft server, there's something like that. So all of those are engines. They are databases in and of themselves. Okay, but the two most prominent are MySQL and Postgres. Okay, I think I even use Postgres a lot more, but I just chose MySQL this time. All right, so MySQL, yes, you will come across this very much. Okay, it's a database. Okay, that runs on a server on a computer. Now, this is a Linux machine. All right, you could install MySQL on a Windows machine and still do the same things I'm going to do here. Okay. Right. So to get started, I am just going to okay. Now I'm trying to log in into the MySQL instance. Okay. So yeah. Now, I tried logging in into the MySQL instance using this command sudo MySQL root. Now, don't worry much about this. The only thing you can pick up is that this just states that this is the instance, the database I'm trying to run. And then my U just means who is the user, who is actually trying to access this. And since I'm the root user, of course, you can see using sudo. I'm the root user. The P just means the password. So I had to put in my password to be granted access. Okay, so now I'm in here. Okay, I can I can see all the databases I have on MySQL. Okay, so right now, these are all the databases I have. Okay, so I have information schema, all of these, they don't make sense. Now I can go sorry, I said they don't make sense. They actually do make sense. They are actually system databases, but I mean you don't want to use this. The information here is not of any relevance to you. All right. So you would want to create your own database, okay, and then use it. So for today's class, I don't know. I think I need volunteers. I need somebody to give me a name. Whoever says it first, I need somebody to say a name that you want me to use here.
Wahab. Use Wahab.
Say again.
Wahab.
Wahab. I don't know if I got that right. Is that the spelling?
Yes.
Okay, so now I have created a database called Wahab, and I don't know what information I would store here. But then the point is, this is how you create a database on MySQL. So now if I go ahead to show databases, I should see Wahab there. Okay, so in here, I can go on to create tables. But before I create tables, I first of all have to use the database. So I could go on to say Wahab, and this just tells the system that look, we are going to start using Wahab as the database now. Okay, so we have created MySQL. We have created a database on MySQL. Okay, it doesn't get. This is how you create databases. Okay, so the usual process when you're building an application is you would first come to the server and create a database. Okay, if you're building an application that has to do with a database, you would first of all come here and create the database. And then after you have created the database, you can then get the details you need to connect to that database. Okay. So yes, we have created use Wahab. We have created a database Wahab, and now we have used it. Now in this database, remember our diagram. We said server, databases, tables, and rows. I explained to you that my computer is a server, your computer too is a server. If you were running on a Windows, a Mac, all of them, they're servers, okay? And then databases, okay? It could be anyone. It could be MySQL, it could be Postgres, it could be MongoDB, it could be Maria, it could be any of them, all right? Point is, as you any of them you pick, right? So if you pick MongoDB or if you pick MySQL, you will still have to create databases, right? Like this. Okay, it's just that for different database engines, you would it will come with different commands. So if I were to do this on Postgres, the field would be different. I think maybe I I will try to do it on Postgres before I leave. Okay, but that's just how it is. Now we have created the database. What follows next? All right. I'm asking that now as a question to everybody. Now we have created a database. What follows next? I'm waiting for
Yes.
responses. Right?
Maybe you should add objects to it or fields.
Object of fields. Okay, depends on what you mean by fields. Actually, when you're after creating a database, the next thing that follows is a table. Okay, so the database, what lives in a database is a table. Okay, so here we go. Table. So I think there should be a command to show tables. I think, okay, so there's no table as we speak. So as you can see, we're trying using in Wahab, all right? There's no table there. So we have to create a table now, okay? So I need ideas. What can we create in the table? What table can we create in Wahab database?
Maybe the first name and last name.
Okay, you want to store first name and last name. That for a table name does not really fly. You don't. I mean, it just doesn't fly. So if you want to create a table, um, you have to first of all decide what data you want to store in that table. Do you understand?
Okay.
Yeah. So if you don't have an idea as to what data you want to store in the table, you are going to you're just going to mess up things. Okay, so when you're creating a database, for one, you have to be very clear on what data I want to store. Okay, or what data you want to store, and then understand the relationships. Now, let me not go too far, but then you first of all have to know what data you want to store, okay, and what problem you are solving. Yes, what problem you are solving, because that would guide your entire process. That would inform you as to how you create the database, or what information you want to collect in the database. Okay, so now you're saying create table. I'm saying that doesn't fly. Okay. And the reason why that doesn't fly is because you cannot just create a table to just store first name. I mean, you want to create a table that stores users. Now, I carefully curated something. I think I'll just open this up with VS Code just to make it easy for everybody to see. Okay, since I can't find VS Code, I'll open it with this. Can you all still see my screen?
Yes, yes, we can.
Good. All right. So we are going to create a table called users. Okay. Now, just to explain something very quickly to everybody, when you're creating a table, there's actually a schematic that follows creating a table. Okay. So if you're creating a table, uh, this comes first. All right. The create keyword. All right. These are keywords. Okay. I'm glad that this text editor actually uses the correct color indentation so that it makes it clear for everybody. All right. So as you can see, the create, right, in red is a keyword. Okay. So create table. Okay. And then what follows next is the table name. So in this table, all right, we're going to be storing the user's information. So we're going to be storing details about a user. And what detail are we storing? Just the username. All right. I would explain what this ID means in a bit, but then for now, just know that we're creating a table of users and we're collecting the user information. Maybe we could even collect emails. We could create a table to collect. We could extend it to have emails. Now, before then, let's look at this. The ID, this ID field here is the column on the table. Okay, so after creating this table, all right, if we go on to look at the table, it's going to look something like this. It's going to look ID and then would have username, okay? And then under ID, if we were to store data inside there, we're going to have something like maybe one and username Ziki, okay? And then if we have another user, we could have something like two, okay, I'll say Wahab, okay? I'm sure it makes sense now to everybody. So UT, the ID here represents it's more like a unique identifier. I'll speak more on that later. The username is another field. Okay, so this is a column or a field, like you said, and this is also a column or a field, like a field too that could exist on or that exists on this table called users. Okay, you could keep adding more and more and more. All right, we'll look at how to insert data into this table as we move. Look at this too. We have profiles. Okay, so we have used the ID. So again, like I said, this is the field ID, the user ID. I'll explain what that is very soon. And we have bio, and then we have, okay, the foreign key is not actually a field, okay, or a column. But then if you were to store data in this, it will look something like this. So one, and then user ID 5, and maybe the bio, you want to say something like, okay, I am a backend developer, okay? I don't know if that's what people put on their bios. So backend developer. Okay. So that's just basically what it is. Okay. When you're creating a table, all of these, all right, the first things that you have to think of first, you have to think of is um the columns, the fields, what you want to collect data about. So the ID, the username, and then what any other field or any other column you want to collect data about. Yes, you would include that here. And then the next thing that follows is the data type. So if you notice, there's a sort of consistency across all of these tables. Let me just take this off. I think that point is clear. So there's a consistency across all of these tables. All right. So we have create table users. Now you have int here. What this int means is an integer. It means that for this particular field in this table, you cannot store anything that is not an integer. Okay, so if you go on to, you cannot have the table users and then you go on to do something like in the place of ID, you go on to do something like um, Frank. Okay, and then in the place of username, maybe you have Frankie. Let me just use that as as the username. Okay. So you can't do this. The reason why is because Frank is not an integer. And now, for those of you who don't know what an integer is just basically a whole number. It's just basically yes, it's a whole number. So like your 1, 2, 3, 4, 5, 6, 7, 8, those are whole numbers, and they fall into the category of an integer. Okay. And then username, you can see varchar. Now, what this varchar means is that um, it can only take 50 characters. Okay, so varchar, it means if I'm typing into username, all right, if I ever want to store a username, that username should not have more than 50 characters. Okay, so I can type as much as I want, but it just shouldn't have more than 50 characters. Is that clear? Is that clear to everybody?
Yes, sir. Yes, sir.
Good. Now, the next thing that follows, I have explained that this is the table, the columns that exist in the table. The next thing that follows is the constraint. Okay, so this is a constraint in itself. This is called primary key. What it means is that is a unique field, is a unique key. So what it's saying is that if I have user one, okay, I cannot have another user. So if I have, for instance, one and Ziki, I cannot have another user take that ID of one. So I cannot have another user come and bear Frankie. Okay, no two users should have the same primary key. Okay, so and this is unique in itself, right? It's a unique constraint. It's saying no two users should have the same ID or ID field. Um, this field is actually going to be referenced by other tables. Okay, I'll explain what that is very soon, but then just know that this is a constraint. So by mounting this here, okay, we're actually saying that look, for this table, this field is a unique field, and this is the field that we are going to reference, or other tables in the database are going to reference. Okay, we'll look at what that reference means very, very soon. The auto increment also passes as more like a constraint, but what it means is that this field can auto increment. So meaning when I'm inserting data into this table, I don't need to pass the ID field. All right. It's not, I don't need to explicitly pass the ID field. Okay. By just simply putting the username, I can create an instance of a user. So what I mean by instance is this is an instance, this is another instance. It's just that this is wrong because of the primary key. Okay, so this is one instance, user one, Ziki, user two, Frankie. Okay, the auto increment says when you are adding a new instance, you don't need to explicitly include the ID field. All right, you can just pass in maybe UT. Okay, and in the database table, you would see the ID 3 come out. Okay. So the idea is that the auto increments reads from the last ID, last ID count, and auto increments it for you for the next instance you want to pass or the next instance you want to add to the table. All right. So enough talking. I'm just going to get this and take it to the database. So we have create user. Can you still see my screen?
Yes,
Can you
sir.
all still see?
Yes,
Good.
sir.
Okay, so create table users. Okay, so I'm going to say ID int primary key auto increment. Now, just like every other thing in programming, you have to be very, very careful about the syntax. If you get the syntax wrong, your code would be wrong. Okay, you would get a wrong output, right? So unique. Okay, now the unique the unique field here also I think from the name unique, it also means that keep this field unique. It's just that the difference between unique and primary key is that with the unique, you're saying while I don't want to have duplicate records of myself. I cannot be referenced by other tables. Okay. So a primary key is unique in itself, is a constraint and is unique. Okay. But it's also saying, look, when you want to reference this table on another table, call me. All right. I am like the ambassador of this table. Okay. So you have the table users. Okay. If you want to reference any element on this table or any instance or any record on this table, what you call is the ID. Okay, why is that? Because you have a primary key stamp or a primary key constraint on it. For the unique, okay, for this one that just has unique, yes, you cannot have duplicate records like the ID field, but you cannot reference this as this cannot be referenced by other tables. Okay, so unique and then not null. Now, the not null, what it means is that it means that you cannot enter an empty data, like an empty data set. So when you're creating an instance, when you're creating a user, you cannot, that field cannot be empty. So you cannot create, you know how you would look at tables, okay? and then you would see something like 4, and maybe this will be empty, and then you have 5, and then you see something like um, Frank. Okay. Oh, sorry, I think I've used Frank. I don't know, or David, or the video. Let me use that. Okay, you can't see. You shouldn't be able to see an empty field. This should not stay as empty. Okay, so that's the idea behind not null. Is a constraint. It's saying when you're creating a table, or when you're creating this particular field, or when you're adding a user to the table, it should not be an empty field. Okay, so if I go on to hit enter, okay, I think we should see our table created. Okay, so if I go on to show tables, I should see tables. The users table has been created. Okay, now if you want to see details about that table, I think there's a keyword called describe, and then we can see users. Okay, so this describes what the fields, everything we just said here. So we have the ID, we have the type as integer, we have null, no. The null they're saying, the no they're saying there is that you should not impute, you can never impute an empty field in this table, or in this particular field. You cannot impute an empty record in this particular field. And then you have the extra auto increments. Okay. Uh, that's how to create a table. Okay. In MySQL database. Okay. And this practice also cuts across many other relational databases. So in the field of databases, we have relational databases and non-relational databases. So we have relational and non-relational databases. But I had said something like this in our last class. Okay. So we have relational. Now, under the relational database basis, we have databases like MySQL, we have Postgres, we have MariaDB, we have Microsoft database. I don't quite know the name, but I know that Microsoft has a relational database. But the most prominent are Postgres and MySQL. All right, these are the ones you would use very much in your backend development field. But even if you know one, the thing is, you just need to know one. Okay, you just need to know any of these, okay, and then you're fine. I personally don't use MariaDB and Microsoft, but it doesn't mean that if I want to use it today, I'm going to stress. I mean, the same principles apply, okay? So even this syntax, when you're creating a table, it follows the same rules, okay? So fantastic. Now we would look at how to insert data into this table, okay? So we'll look at how to insert data into this table. Now, there's something also I just also have to put this out here. Is this, am I still, are there still people in the class? I like to I don't know, since I can't see your screen, I feel like I'm talking to myself. But I like to believe that all of us are still very active. Okay. So I want to bust the myth. Okay. As you progress in your journey, okay, I think I should even seize this opportunity to tell my own story. So when I started backend development, many years, I want to say many years ago, but some years back, yeah, um, I started my backend journey with databases. Okay, so I had done a bootcamp program. Actually, I started with the intent of becoming a data analyst. Okay, so it's just that the instructor, then Professor Alan Paradise, he he made us see how databases can be used to solve problems, how just by being able to model data we could solve problems and business problems with that knowledge. Okay, so I had not written backend code, all right, when I started my journey. I just started with databases. I learned about how to create tables, how to form relationships, how the relationships work between entities or tables. And when I eventually started writing backend code, everything made sense. So long before I even started writing backend code, I could sit down and think of how Facebook's database is structured, how they architected the entire system. So I like here, I think I tried to do something like that. So I could see that, okay, so every user on Facebook has profiles. And so a user can have only one profile. A user should have only one profile. Okay. A user can have as many pictures. Okay. So there's a one-to-many relationship there. I'm not saying you wrap your head around what that means. I'm going to explain what that is. But then the point I'm trying to make is this, that I soaked myself first in the study of databases. I learned databases first, particularly relational databases. And then that made my backend journey easier. I mean, 1 month into my study, all right, I could already tell, even though I will not say I did it to company or industry standard, but of course, I could I could tell how certain systems were built. I had an idea as to how certain systems were built. And that's because I understood how to model data. All right. So now in the industry, now I'm fully in the industry. There's this thing that goes around that, if you know how to use ORMs, now so ORMs are just basically a wrapper around databases. So they abstract away all of these things I'm showing you here. They abstract it away from the developer. So they they will most likely tell you that, ORMs, if you know how to use ORMs, you will not have to worry about all of these anymore. All of these things are not important. If you know how to use an ORM, you'll be fine. Yes, truly, you will get around many things, but many of the details will be hidden away from you. Okay. And many times you would run into problems that will require a knowledge of this. Okay. So that's the reason why I'm making it bare bone for you. I want you to see how things work under the hood and then take it gradually. All right. So enough of that. Now let's see how we can insert data into tables. Now, here, this is how you insert. So I'm just going to take, or better still, let me just write it. So insert into, of course, this is a keyword, insert and into, okay? Is a keyword in most relational databases. So even if I'm using Postgres, all right, I'm surely going to come across this insert, just like the create table. Okay, the insert is also a keyword in databases. So insert into users. Okay, now the users, where is it coming from? Is the database table. It's the database table name. Okay, so as you can see, show tables, we have just one table. We have users. Okay, and then in the table, we are trying to insert data into it, and we are inserting um, into what field? We are inserting username. Okay, now here's the thing. I had said here that we don't need to include the ID field, but I think I'll just include it for um, just so you fully understand what I'm saying. So I'm going to include ID, okay, and then values. Okay, so I have one and Ziki. Okay. Now, after having done that, best believe this data has been added to the database, and of course, this is how I'm going to show it to you. So select this from. I would explain what this is as we progress. But for now, just know that we are trying to see that table and see the data that lives in that table. As you can see, all right, we inserted into the table. We created the table, we inserted data into the table. Okay, so insert into users, and then we passed the field. So we have ID and we have username. So we have ID, username, and then we inserted into this using these values. So ID refers to one, Ziki, the other field, the username field. Okay. Now we're going to do another thing. We are also going to insert. Okay. So if we do this, can you see the error we are getting? Who can explain to me? I need somebody to explain to me why we are getting this error. If you have been following so far.
You're having the same ID.
Yeah, we are having the same ID. So no two users should have the same ID because this is a unique field. Okay. Now let's go ahead and do something again. If I go on to do, okay, let's say I use two. Okay. And then I do this, I do Ziki. Now, why this? Who can explain why?
I think since we initially said username should be unique, so if we are having
Fun,
Ziki the first row,
why?
we can't be having second
Fun.
row
Fantastic,
security.
fantastic. That's the reason why. So earlier when we created the table, we had said that look for the username field, it has to be unique. All right. It cannot be this, no two records can have the same username, or no two persons can have the same username. And in fact, too, think about this. When you go on platforms like Facebook, you notice that, okay, let me not use Facebook. I think Facebook is a bit, I've not used Facebook in a while. But I remember to go back in the days when we used to go. I don't know if any of you here has used to go before. So when we used to go, that was the time when username was really a thing, right? So on softwares, on social media apps, you were identified by your username. Now we could have users bear the same name. So I could be Ezekiel Udwakabasi and see another person with the same name, right? Usernames on to go then, if you try to create a username that belongs to somebody else, they would immediately tell you, look, this username already belongs to somebody else. Now, the idea is they are storing their records most likely in a database like this. And when you try to create a user with another user's details, uh, this error kicks in. All right. So they throw this error back to you. This error comes from the database. Now you can see how it works. Okay. So I hope that's clear to everybody. Is it clear to everybody?
Yes, sir.
All right, moving on. So insert into users. Now, I also said something that I don't need to pass this field. I don't need to pass uh, um, this into the database, the number, the ID field, because that is already on auto increment. So if I go on to do something like Oluchi, I don't think we have Oluchi in this table. Let me go ahead and insert that. So Oluchi, if I want to do this, I think I need to take this off. Yes, I need to. So if I go on to do this, I have created Oluchi into the database. And guess what? When we check the data in the table, when we check the data in the table, we are going to see Oluchi, okay, with the ID of 2. Okay. So what that means is the auto increment just takes the last count and increments it by 1. Okay. So that's just basically how to create a table in a database. So back to our slides. We have seen how to create a database on a server, on a MySQL server. We've seen how to create tables and, of course, how to create rows. So um, the create table, this is the command for it. I would send this to the group soon. After this class, this is how you create a table and this is how you insert into the table. Okay. And I've shown you the other nuance around that. So when you have an auto increment, you don't necessarily have to pass it every time you're inserting into a database table. Okay. So moving on, we are done with this project now. Now, this the Holy Grail. I got this quote from a software engineer I respect very much. So he said, if you're building a backend system, always start with the database schema. It's not just a technical step; it's a blueprint that informs everything else. A well-designed schema clarifies your data, guides your API structure, and simplifies your business logic, and ensures long-term maintainability. Skip it or do it poorly, and you'll find yourself constantly problems downstream. In backend development, schema design isn't just the first step, it's the roadmap. This is so true. All right. Every system, every backend system has to have a schema, has to have a structure. Okay. Without that, you're really going to struggle. You won't make sense of how data flows within your application. In fact, I like to think the hardest part about backend development is just being able to architect the data road. So knowing where this data is stored and how you can retrieve the data and how you can make use of that data, all of that is embedded in the database schema. All right. So being able to articulate that sets you apart, okay, and makes your backend development journey very, very easy. Okay. So that's why I had to put it here. And it's something you have to keep in mind. Now, building blocks for schema design, entities, relationships, and data normalization. We may not look at all of these for lack of time, but I'll try my best to explain what they are. And now these things are very, very crucial. Like I said, when I started, these were the things I was exposed to, right? And these things, I promise you, they made my backend development journey very, very easy, right? So entities and data relationships and data normalization. Now there are rules around all of these, and we'll be looking at them very soon. I think I have just a few minutes left, but let's go on now. Entities are just real world objects or concepts that we store data about. So in very, very simple terms, that table that we created, the users table, it can be regarded as an entity. Now, what data are we storing? We're storing data about users of the application or users. The users we want to store details about. Yes, that's what it is. So entities are basically just tables. Okay. Now, so an example is students, course, books, authors. I mean, you can name it. Depends on what you want to achieve. Now, data relationships. Data relationships refers to the logical association between entities in a database that define how data in one table is connected to data in another table. These relationships help ensure data consistency, enable efficient querying, and represent real-world associations between objects in a structured and meaningful way. Now, all of that is semantics. In the end, it just boils down to these three: one-to-one relationships, one-to-many, and many-to-many. Now, there are many other ones. There's polymorphic. I just did not want to include that here because it's not so used, but then it's also a thing. So you will come across it someday. Right? One-to-one relationship. Now, I'll start with this. Before I'll go back to this, but let's just quickly look at this. Beneath the relationship, what exists? Primary keys, foreign keys, and composite keys. We had seen what primary keys are when I was here. Let's see. Yeah, so we had seen it. I tried to explain that it is the unique identifier, is a unique identifier in a table, and it's what other tables make reference to. Okay, so primary key, foreign keys, and composite keys. Okay, and now look at this. All right, best way to describe. Look at this table very quickly. Everybody, your eyes should be fixated on this table. So this is a okay. I don't want to say what it is about, but who can tell me what's this table about? Hello, I need feedback from everyone in the class. Am I still on? Hello. Okay, I need to go back. So everybody who can tell me what's this table about?
Let me just try. I think the week is about list of groups. Say the title, the author. Is it list of books?
Fantastic.
Okay,
That's
yes,
what it is.
list of books. The title, the
Yes.
author, the year it was published, how many pages are contained inside the books. So it's just basically about the book.
Fantastic. I wanted to ask who has read any of these books, but I promise you will not enjoy any of these books. I tried reading one and it wasn't Pride and Prejudice was the one I read, but I didn't enjoy it. Now back to business. Yes, this is a table, all right, that lists books, that stores data about books. Okay, so Lord of the Rings was written by J.R.R. Tolkien. I don't know who he is. The genre is fantasy, year published 1954, and it has these amount of pages. These are just books. Now, who else can notice? Can you spot what makes each book in this table unique? Like what's that thing that you can take and say, okay, with this I can identify a book and map it to the book like exactly. I don't know if that makes sense. So what's that unique thing about each book? What field from the book ID to the title, author, genre, year published, and pages? Which of them can you take out and say, look, if I know the ID or I know the title or I know the author, if I know any of these, I can tell which book that refers to. Which of these fields gives you that clue?
Book ID.
Book ID. Okay, of course, I wrote it out here, primary key. Now, the thing is, you see, Pride and Prejudice, all right, if we were to use this as the primary key or as the unique constraint, tomorrow somebody could wake up and write another book and call it Lord of the Rings. Okay. Another author could wake up and write a book and call it Lord of the Rings, and it will still fly. All right. Another author could wake up and write a book called Pride and Prejudice. Now, author, of course, here we can see Jane Austen wrote two books, Emma and Pride and Prejudice. Okay. Genre, many books can belong to this category of genre. Many books can be published within the same year. Many books can have the same pages, the same number of pages. Okay. So if we are to use any of these fields to uniquely identify a book, we'll run into problems. So that is why we have the book ID. The book ID just simply tells us that look, this field or with this identity with the ID, I can identify a book. I can map it to one copy of a book or one copy of one instance of the book, all right, in this table. Okay, so book ID, it makes sense to call this the primary key. Okay, so meaning that if I have 1, 2, 3, 4, 5, anywhere I go in this table would always refer to Lord of the Rings. So even if I have Lord of the Rings in many places, if I have the ID 1, 2, 3, 4, 5, I would map it to this particular Lord of the Rings that was written by J.R.R. Tolkien and belongs to the genre fantasy and was published in this particular year. Does that make sense to everybody?
Yes, sir.
Good. So the definition, primary keys are just unique identifier columns. Okay, so imagine a library with a book collection. Each book has a unique identifier, like an ISBN number that allows you to find it on a shelf quickly. Similarly, a primary key is like an ISBN for each row. So imagine this. Now, most books, all right, that are published, if you check the back, they usually have a number that is unique to that book. So no two books can have the same ISBN number. So you can liken that to a primary key. Okay. Now, moving on, foreign keys. Foreign keys is an attribute or set of attributes in one table that refers to the primary key of another table. Now, this here I have to take my time. A foreign key is an attribute or a set of attributes in one table that references the primary key of another table. So a foreign key is an attribute. What is an attribute? All of these, the title, the author, the genre, the year published, and pages, all of these refer to attributes, right? So me saying a foreign key refers to a set of attributes. What I'm actually saying is that um, on a table, I could have an attribute, right? Like maybe pages that refers to another table or another primary key living in another table. Now, scroll down, look at this. We have guardian and we have children. Okay, so picture a school, all right, where you want to store details of the children or the student. I should have said student here. But anyway, guardian and children still passes, all right? So we have guardians, children. These are all the children, maybe in a church or a school. Okay, so we have Josh Williams, Williams, Pearl, Sunday, Ayami, David. And then the guardian table, these are all the guardians. So this person, Sunday, has his occupation is engineering, Williams, pharmacist, David, politician. This makes sense, right? Of course, the primary key, the unique identifier of this table, what this means is that if I take the ID of one, anywhere I go in this table, all right, every time I take that ID of one, I'm going to have this particular instance. I'm going to have an instance where the name is Sunday and the occupation is engineer. So even if I have another person who bears the name Sunday in this table, I'm still not, if I don't have the exact primary key, I'm still not going to locate the person I'm looking for, all right, or the record I'm looking for. Okay. So this is the primary key. And on the children table too, we have the same thing. We have the primary key. We have 1, 2, 3, 4, each of them representing a particular child. Okay. Now we have guardian. The guardian is, we're saying this is the foreign key. The foreign key here, if you notice, all right, we have a guardian foreign key. It is actually referencing something. It's referencing the primary key on the guardian table. So again, the guardian, it lives in the children table, is an attribute of the children because, I mean, every child has a parent. Every child has a guardian. There's no, the word zombie is just thrown around for, I don't know, semantics, but there's no child that does not have a guardian except the guardian is late. Okay, so every child has a guardian, and it makes sense to have that guardian uh, or to have a child reference to the guardian. All right. So Josh Williams, all right, is a child of who? Of Williams. So Josh, okay, so we'll identify a child by their name. So this is Josh, and this is the parent's name or the guardian's name. So we have the child Josh, and the guardian here, you're saying two. This is referenced, this references another key, another primary key on another table. So we have two being referenced here, right? So Josh William being a primary key is referenced here, right? Williams being a primary key on the guardian table is being referenced here in the child table, okay? Pearl Sunday, okay? Sunday is a guardian. And of course, you can see it's being referenced here in the primary key as one, okay? So you can see the direct correlation, okay? So we have guardian as the foreign key on the children table being referenced at the primary key level on the guardian table, okay? So that explains what a foreign key and primary key is. I don't know if that's clear to everybody. Is that clear to everybody?
Yes, sir.
Yeah. All right. So we also have another example now, and I think I'd leave this one to everybody to attempt. So we have class primary key, and we have students primary key. Just quickly look at this table and tell me what you can see. I need somebody who is paying attention to just quickly describe what they can see. I'm waiting. Who has an idea? Somebody wants to say something. Yeah,
Hello?
go on. Yeah, I can hear you.
So the class ID,
Okay.
which is primary key
Yes.
for the first one, the first
Yes.
table. So when we look at that, you can see 101, 202, 302. And
Yes.
the second table on our class ID, the foreign key. Here we are using the foreign key to reference the primary keys.
Fantastic.
First table.
Fantastic. That's just what it is, right? So primary key on one table being referenced as a foreign key on another table. Okay. That's just the concept behind it. So primary and foreign key. Now we have composite keys. Okay. So composite keys are just a combination of columns to form a primary key. Now, the idea is, remember, a primary key is just basically a unique identifier column or a unique identifier attribute. That's what it is. All right. Now, a composite key is saying, look, I don't have to. So on this table, all right, every time you want to reference a record on this table. On this table, have I'm not going to have one ambassador. I guess that's the best way to put it. I'm not going to have one ambassador. I'm going to have two ambassadors. I'm going to have two columns or two attributes that will stand as the primary key. Right. So I know that may not be too clear, but just watch this. If imagine you are a student, all right, in a university. Many of us, I mean, we went to school where or in the university. So you have a student who has this unique identifier and has, of course, their names. And then they all took courses in the school. So they had I know many of us who did computer science, we did CS. This code is very common to most of us. Math, history, whatever. But these are all primary keys, okay? And then the course names, these are, of course, every course has to have a course name, and then the department that is offering the course. So keep this table in mind: students and courses, both are two different entities, okay? Now, when a student takes a course and you want to compute their results. Okay, so you want to compute the result for that student. Okay, now it will not make logical sense to keep that result here in the student table. So to create another field in the student table and call it results. So if we are to do that, so keep this in mind. Let me go back to my writing document. So if I have, for instance, I have student, this is a student's table, and what do I have? I have ID, I have their name. It will not make sense for me to say course. Oh, sorry, grade. Of course, if I were to do this, I would have something like one, maybe Ziki as the name, and then the grade. Now, if I were to go ahead and say A, this A, what is it for? What am I storing? What is this A referencing? Right? It will not make sense to do this, right? For the student. Same thing with the course. I mean, if I were to do the ID, to write the ID of the course and write the course name, and then do department. This will not mix. Oh, sorry, department and then grade. This will not make sense, okay? Because if I say the course is CSC 101, okay, or computer science, and then I say this course is offered by computer science, home science, and then I say the grade. If I go on to put B here as a grade, this grade, what is it exactly referencing? A grade, for me to say a course has a grade, all right, it must mean that a student or somebody must have taken that course and scored a particular or had a particular value as the grade. So this does not point to anybody. So that is why it doesn't make sense to store that here in the course table. Okay, so a better use would be to do something like this. So you take the student ID, create a new table, all right? You have student ID, you have course ID. Now, here's what's happening, okay? You see, the ID here, the student ID is a primary key on the student table, okay? And on this particular table that we call result, that ID is being referenced as a foreign key. Okay, I think that concept is clear. And then the course ID, all right, meaning the course the students took, all right, is also being referenced here as a foreign key, pointing back to this as the primary key on this table, on the course table. And now it makes sense to go ahead and assign the grade. So it makes sense now. When you look at this table, the data makes sense. So you see the students who took the course and the grade they actually got from taking the course. Okay, so what happens here? You see, here in this table, two columns or two attributes okay, denote the primary key. So student ID, course ID, both of them stand as the ambassador of this table. They stand as the uh, referenced value. So if you want to reference a value in this table, you need these two. Otherwise, you can't make sense of the data that you are extracting. So if for instance, I take just the student ID, I want to make this alone the primary key. This will not make too much sense. If I take just the student ID, the student has a reference to the course. Okay. So if I took, for instance, the student ID and I took the grade, okay, if I gave you that data and said student ID and grade without the course ID, it would not make sense to you because you would question, okay, so I have the student ID and I have the grade. The grade is for what? Why does the student have a grade? Why is the grade there? But when I include the course ID, it makes sense to say, okay, so this student actually took this course, and by virtue of taking the course, they had this grade. Okay, does that make sense?
Yes, sir. Yes, sir.
Good. So that's the idea behind composite keys. Composite keys is saying I'm not using a single attribute as a unique identifier. I'm using multiple attributes as unique identifiers on a table. Okay. So now we are going to look at this in code and
Please, can you repeat again? Hello?
comes to play.
Can you
I
hear
am
me?
going to take this off. This was just
Can you hear me?
my board for illustration. So we have created the users now.
Hi,
Yeah, so
yeah.
we have the users table with two
Can someone hear me?
users. Very quickly, let's see what this is. Now, this class is not.
Someone is talking to you.
Okay, okay, please go on, go on.
Oh, your last statement, you mentioned that composite skill, we use multiple multiple queue to identify.
Yes, yes.
Oh my God. I just wanted to repeat that. I was
Okay, yeah. So composite keys, you use multiple columns to represent that instance as a unique instance. So looking at this, all right, we have these two, all right, the student ID and the course ID as primary keys. All right. They're actually called composite keys, but then you can interchange them. So for this particular table, all right, these two are primary keys and they are called composite keys. The idea is that these two stand as the unique identifiers for every instance of this table. So every time you pick a record in this table, these two have to be there. All right. Yeah, they tell you, they point to the exact record you're looking for in the table. Just like on the books table where you have this as an instance, you have this as an ID, as a primary key. All right. Every time you pick this primary key, anywhere you go, as table is concerned, if you impute here, right? So this primary key is like the ambassador of every other field here. All right. Here with composite keys, we're trying to achieve the same thing, but it's just that this time we don't use a single record. We don't use a single attribute. We are using two attributes this time. All right. So this with these two attributes, if I impute this into the system, if I search with this, I'm going to have this record. Now you may be thinking, let's reverse the process. You may be thinking that, okay, why is it important? Guess what? We can have another student in this table. Okay, so we can have. Let me do it this way. I get that confusion. Say we have student ID. Please pay attention because this place can be mind bending for a lot of people. But I'm trying a possible best to explain every nuance around it so that you don't get confused. So I have student ID and I have semester, and I have grade. Now, it is possible that I have a student whose ID is 1, take a course called home science, and then, or commerce, as the case may be, then in the first semester, so I would say maybe first, and come out with a grade of A, and also have the same student, okay, take another course let's say math in the first semester and come out with a grade of B. Now, if we don't have these two as the primary key in this table, and we just have only this as the primary key, we take only the student. What this means is that if we are searching based on this particular student, we are going to have two of these results come out, and that defeats the purpose of what we are looking for. All right. So with the primary key, you're supposed to use that to get every attribute or get the entire instance of that field you are looking for, or of the record you're looking for. So if I take just the student ID alone, okay, if I'm searching based on the student ID alone, these two match that. And that does not exactly tell me what I want. All right. In this case, I am looking for the student ID and the grade. I'm looking for this, the grade that a student had when they took a course. So if that is what I'm looking for, these two would pass as the primary key or as the composite key. Because now I can tell, okay, so I have the student ID and I have the course ID. That tells me the grade. I can use that now to search for the grade they got from taking the course. Okay.
Please
Now,
move
also,
on. I understood.
is it clear now?
Please move. Yeah, please move on. I understood
No.
since.
Oh, okay. No problem. Okay, so very quickly, let's do it so that we wrap up. My terminal here, my Kanban board. Hold on. Yeah. So we have created this table. I was going to show you. We have these two users. Select. Of course, you can see the two users we created, and now we have profile. Now, a profile has primary key as the ID. Of course, the user ID too refers to the user ID. So the user who owns the profile. Can you see it here? So the user ID refers to this. Now, before we even there was a part I jumped. I don't want to jump that. Let me let me explain this one. At least we go home with this. Now, one-to-one relationship, one-to-many relationship, and many-to-many relationship. This part is very, very crucial. Now, you may not understand it fully in the first class because I like to think that this is the first time most of you are hearing this, but then it's something that you would always fall back to. It's like your go-to model when you're modeling data. In fact, even with people who when NoSQL databases came out, when non-relational databases came out, there was this argument around this particular concept because this has been around for ages, for decades, right? So the people who created NoSQL databases, they created it to kind of uh, bypass this model, all right? So they thought by creating it, they could get around this model. But many people who use NoSQL databases, they still fall back to this. They still look for structure. The idea is this. When you have two records, okay, as we can see here, I think I should use this to explain. Now we have users and we have profiles, okay? Every user, think about this. On your Facebook app, you as a user who is using Facebook, how many profiles can you have? As a single user on Facebook, how many profiles can you have? I'm throwing this now to everybody. It's a question. You can only have one profile, right? So you are user one, okay? You are user one, and you can only have one profile, okay? Now, that explains a one-to-one relationship. What that means is that if I am as a single user, I can only have one profile. Perfect. Country and capitals. So can the country have many capitals?
Yes.
Is it possible? Huh?
Yes.
The
Yes.
country can have many capitals.
No. Sorry, no.
Just one.
Just one. Fantastic. So what that means is that one country, one capital, right? That's a one-to-one relationship. Okay. A country can only have one capital, and a capital can only belong to a country. All right. Moving on. And let me think of another example that explains a one-to-many relationship. Okay, yeah.
Somebody
Father and
hasn't done
child.
it.
Somebody's giving an example. Tell me.
somebody having many friends.
Yeah, somebody having many clients. I mean, so as a user, you can have many clients, and those clients would belong to you. That's a one-to-many relationship. On Facebook, yeah. How many posts can you make?
It's unlimited.
Yeah, so meaning that a user can make many posts, and each post would belong to a user. So that what kind of relationship exists there?
It's a one-to-many.
One-to-many, right? Does it make sense to everybody?
Yes, sir.
Good, good. So looking at this now, our users and profiles table, what can you see? Let's quickly let's do it. So guys, okay, for tutorial sake, I'll just type create table, profiles. Now this is another table I'm creating in the database. When you're building an application, of course, when you start the program, we will do this, but it won't be in this format. We'll be using ORMs to do it. But the idea is this: as you understand this, using ORMs will be much, much easier. All right. So ID, of course, that is the table, the attribute in the table, the first attribute, integer, primary key, now primary key, auto increment. So I'm sure you guys already know why that's the case. Why I'm doing that. Please also help me help me cross-check the spelling just in case I get it wrong. I don't want to get an error. Auto increment. I think I got that right.
No, it's
User
correct.
ID, user ID, int, unique. Okay. Now I'm sure you know why that is unique. Because you don't want to have two user IDs belonging to a user. So this user ID, as you can see here in the table, this is a foreign key. Okay, all right. The user ID field is an attribute. It references this table. It references a record in this table. Okay. So bio, text, and foreign key, user ID. So guys, if you truly understand this, trust me, most of your backend problems would be it will be easy for you to meet a client and the client to tell you about their business problem, and immediately you just architect a solution for it. I mean, this is your go-to place when you confront a backend problem. So moving on, I think we've gotten that right now. So now we have created a table called profiles. Now the idea is that every profile should reference the user. So if I say select, or let me not do that because that field will be, the table will be empty. So desk profiles. Now, what this tells me is that the user ID, all right, is referencing the user table. Okay. Now, it's a foreign key. This doesn't really go into much detail. If we were on Postgres would I really state it out that look, this key is a foreign key and it points to the exact table. Anyways, would maybe subsequently we'll look at that. But now we have created these two tables, user and profiles, and of course the unique. Why we have the unique there is we don't want to have duplicate records because this is a one-to-one relationship with the users. We don't want to have duplicate records. Okay, so I'm just going to insert into the profiles table. I would grab this. For lack of time, I would have typed, but I'll just grab this and put it there. Now, okay, so we have insert, we have ID. Now, you see, the reason why we are not including ID here, who can remember why we are not including it? The auto increment thing, right? So we don't have to include it because MySQL would automatically do it for us. Now we have ID 1. What does this 1 represent? The 1 represents the user ID. And where's that user ID coming from? It's referencing user Ziki. So 1 references this particular person here. Okay. And then user Ziki is a backend developer. And okay, that's the profile of, that's the bio. Yeah. So the bio is this, so backend developer and trader. Okay, so backend developer and trader, right? So if I go on to hit this, what that means is that now in my profiles table, I actually have profiles. Let me get that data out. So what that means is that I have user Ziki as a backend developer, and this user ID references this. So let me see something. If I go on to do this, if I go on to do one, and I try to create another profile, I try to create another bio. So I say something like front end developer, front end developer. Okay. If I do this, who can tell me why this is a problem? Why I'm getting this error?
Because you have a one-to-one relationship and you cannot have another entry that is attached to the user ID.
Fantastic. Fantastic. Now, if I do this, who can tell me why is this throwing an error?
User ID doesn't exist.
Yeah, true. The user ID does not exist. So now, if you look at our records, we have Ziki, Oluchi, and each of them have user ID of 1 and 2, respectively. There is no user with an ID of 3. So when we try to create a profile for the imaginary user 3, they throw an error at us and say, look, we can't create any profile for a user with ID of 3 because there's no user with the ID of 3 to start with. Is that clear to everybody? Is it clear to everybody? Have I lost?
Yes, it is.
Yes, sir. It's
Yeah.
clear.
Right. Good. So that's the idea. That's the concept, right? So if you must create a new user or create a new profile, given that every profile has to reference the user, right, or reference a user, you have to pass in the user's detail or the user's ID, all right? So as you can see, they said cannot add or update a child role, a foreign key constraint. I did prevent. I don't get it, but of course you get the idea, right? The foreign key has to be present. Or sorry, the primary key on the table you're referencing as the foreign key has to be present. Okay, so that explains a one-to-one relationship. Okay, now let's look at one-to-many relationship. Now, just like your Facebook, all right, every user can have as many posts, all right? So many of you can't count the number of posts you've made since you opened your social media account, all right? If I take this, I'm just, for lack of time, I'm sure everybody gets this. The post ID has to be an integer. This time there's no constraint. It's not a must that this can go missing. The tag, I think, is even bad practice. Maybe I need to put it constraint, not null. No. Sorry, I'm referencing the wrong table. Yeah, this is the table I actually want. Post. All right. So create post. Now, if I take this and I put it here, the ID, user ID, title, content, foreign key. Now, all right, this is a one-to-many relationship. All right, so a user can make many posts. What makes this stand as a one-to-many relationship is the fact that there is no unique constraint on the user ID. So what that means is that I can create as many posts as possible, and many of those posts can refer back to a single user. Okay, so with the unique key here, what it meant was if I create a profile, I cannot create another profile belonging to the same user. But with the post, I can create as many profiles, also as many posts as possible, and have all of it referenced back to a single user. Does that make sense? So if I go on to do this, if I take this and I put it here, just for lack of time, I would have typed it out. Hope it's not. Oh, I bad. Cancel this. Let me be sure. So I'll take this, paste it here. Why is okay? Yeah. So I have created this post table, and of course you can see it. If I describe my table, if I describe the post, I should see it. All right. So I have ID, user ID, title, and content. Fantastic. So I can go on to add posts to this table. So let's see, insert into post. I am going to take this and post it there. I don't know if I can expand this out a bit. Okay, so I'm going to take this and put it here. Now, look at this. The user ID, this one refers to the user ID. The title refers to the second field here. So this field, how I built my API, is the title, and then the contents. Of course, you can see contents of the API title. So if I go on to hit enter, this has been added. I can go on to do the same thing as well. So, okay, so I think I had curated nice content. So I have, just a second, I have this too as well. So insert into post. So I'll take this and paste it here. All right. So insert into post, I have user ID, title, content. This time, while I'm still the same user, I'm posting a different thing entirely. Of course, you can see this on social media when you make different posts. So if I go on and hit it, you can see the row has been entered, the table, the post has been created. Now the second user, I'm going to take this again and post it. Yep. So this is the second user, all right, trying to make a post. Now I'm going to do something funny, and I'm going to paste. Oh, okay, let me do this. It entered before I even typed. So if I do 3, all right, of course, we should get an error. So cannot add or update a child folder, and that's because user 3 does not exist. Now moving on, let's go on to check the fields because we are almost out of time. So select from profiles, from posts. Okay, now you can see the user with ID 1 made this post as his first. User with the same user made this another post, and then the second user made the same post twice. This is very applicable when you are making posts on Facebook. I mean, it's so applicable. You can make as many posts as possible, and all the posts would be referenced back to you. So this explains a one-to-many relationship. Now, I'll just quickly talk about a many-to-many relationship. Okay, the example we made earlier. Let's go there. That example perfectly explains a many-to-many relationship. Now, we had the student and we had the course. All right. So every student can take a course. All right. And a course can be taken by many students. So as a student, you can take many courses, and a course can be taken by many students. Think about it. When you were in school, all right, when you were preparing for an exam, you were not preparing for the exam yourself alone. You were preparing for the exams with many other students. In the exam hall, you had many other students who were sitting for the same exam. So you can say that the course had many students, and as a student, you took many courses because that was not the only course you took when you were in school. You took many other courses. That kind of relationship is called a many-to-many relationship. Is that clear to everybody?
Yes.
Yeah. So that's a many-to-many relationship. So as a student, you took many courses, and a course will belong to many students. All right. So how you model those kind of relationships is you use a pivot table. This table is actually called a pivot table. Okay, that you come across it, but the idea is that it's a way of joining the two tables together, and you would use a composite key. Okay, it's in tables like this where you use composite keys. So you have a reference to the both tables that have the many-to-many relationship. So the student has a many-to-many relationship with the course, and same for the course. So you would always reference it using a pivot table, and that pivot table will have composite keys. So if you look at this, back to our example where we have a user and or post tags. Okay, for those of you who are Twitter freaks, with many, I don't know, there's this thing about tagging. So when you make a post, you can have, even on Facebook, I think when you make a post, you can tag as many friends as possible, I guess. Or I don't, anyway, but you have a post can have many tags, okay? And a tag can belong to many posts. So if you make a post and tag it as software development, another person can make a post and also call it software development, okay? And the tag in itself, software development, can belong to many posts. Okay. So there's a many to many relationship exists between posts and tags. So because one post can have many tags and a tag can have many posts. So in situations like that, you want to have a composite key. Okay. So you can see here, we have the post ID and the tag ID, each of them representing the posts and the tags. Okay. And of course, like I explained, that you can't take out a post and make it stand out in the post tag table. I mean, you can't take out a post ID and make it stand as the primary key. That will not make sense. Okay. So both of them are now the primary keys in the table. Okay. So I will take this again, but before I even do that, I think I must create a tags table. All right, before I go on to insert values into the post tag table, because if the tags table does not exist, I won't be able to do that. So now the tags table has been created. It has just an ID field and a name, and the post tags. Take this. Now I have created the tags and a post tags table. So if let's see, just to be sure, show tables, all the tables we have in our databases, in our database rather. So post tags, post profiles, tags, and users. Now all of these are the tables we have. The post and the tags have the post and tags have a many-to-many relationship, and that is modeled using the post tags field. So moving on, I'm going to add to the post tags, and I want you guys to tell me what you see. Let me take this off so I get everything exactly. Okay, so if I take this and put it here, now I'm trying to create insert into the post tags table. If I do this, this is what I get. Who can tell me why this is the case? Is anybody following?
Yes.
Okay. Somebody's saying something. Yeah, go on. Who was talking?
I think you wanted to check if we were following, and I said yes.
Okay, yes. So I'm saying, why is this the case? Why? Who has an idea why this is not following through? Why this is not working? So I'm trying to insert into the post tags table, and I'm getting this. So why is that the case? Okay, so the reason why this is the case is because in the post, I think in the tags table, there is no record. We don't have any record in the tags table. So we are not referencing any field in the tags table. And that's why this is throwing the error back at us. As you can see, we are trying to reference one when we create a tag here. But the problem is in the tags table, we don't have any field there. We don't have any record there. So this is telling us that, look, you can't create a post tag when there's no tag. Okay. I don't, let me see if we have a post. Okay. Yeah, we do have posts. We had created posts. Yes. So while we have posts, we don't have tags. And so that's the reason why we have that error. Okay. I hope that's clear. So now we are going to insert into tags. We're going to add into the tags table. Okay, so you already know how to insert into a table. So if I insert into tags, I'm going to insert tag as one of the tags. And if I do so, I'm going to have, sorry, I'm going to have this as a record in the tags table. And now if I go on to insert into the post tags table, now I'm going to have this as a successful operation. And the reason is because there is a post, all right, in the post table with an ID of 1, as well as a tag with an ID of 1. Okay, so That is why this is possible. Okay. And that explains a many-to-many relationship. Yeah, my time is fast spent, but I want to believe that this is clear to everybody. I'm open for questions now. Do you have any question? Let me go back to my slides. From the beginning, we started with the fundamentals. We learned about what a database is, a server. From our last class, we said a server is more like a computer where you store just a computer that has networking capabilities. And then databases, this is the key part. So a database lives on a server. The server is your computer. Databases live on those servers. And in those databases, you have tables and rows. Okay. So yes, questions, please. Open for your questions now. Do you have any questions regarding everything I've explained?
Sorry, sir.
Yeah.
Sorry, I wasn't in the last class, so I don't know if you talked about data types. So my question is when creating the what's it called? Should it be the table or okay? Where we use the username as varchar. What if we use like string? Because string is also a data type. My best of knowledge. So string is also a data type. So is there
Yes.
a difference between using the strings and using the varchar?
Okay, so in relational data or in relational databases, they don't describe that thing you call string as string here. All right. Here we have varchar, we have text. Okay. We don't have strings yet. But again, all right, this is a world of its own. Databases, they are a world. They are in computer terms. Software engineers will regard them as processes. It's a process on its own. It's a machine. It's a system on its own. And your code itself is another system. Now, in your system, you regard it as strings, and you are not wrong. When you start using ORMs, all right, object relational mappers, all right, the ORMs, they act as an intermediary between the database and your backend application code, all right? So when you're talking to the database using your ORM, you would refer to this particular field here as a string, all right? So why I'm saying that is you don't throw away your idea of this as a string. It is still very valid. All right. In fact, I wish I could show you my code where I have this as a varchar. Let me see. If I try, I try to open it. But then where you have this as a varchar, this is a string in itself. Okay. When I refer to it in my code, I refer to it as a string. But on the database level, it is a varchar. That's just how it works. I don't know if I've answered your question.
Can I add to that?
Yeah, go on.
So a variable character, it's which is what they call a varchar,
Yes.
has limitations to the number of individual entries you can do. I think about 2 to 5 or thereabout. Why for
Yes.
a text, it is unlimited. Now for variable character is defined in its name itself, variable character. So it can take alphanumeric values, including symbols and other things. So a text will do the same thing, but for something like a user ID or a username, you don't need much number of characters. So which is why it will be preferable to use what they call a varchar for username, because you can define it. But something like an address, you would rather use a string or the relational database term, a text to actually use, because you don't exactly know how many input you are going to enter for an address. But for username, your username should not be more than maybe 50 at most. So it's just best to use something like variable character to define its data type. I don't know if that makes sense.
Yes. What he's saying, the person who asked the question, is that clear to you?
Yes, of course. Clear. Thank you.
Okay. Very quickly, I just wanted to show you that thing you talked about. So this is a Python code. So I have a model here. This is what you talked about, string. So this is a model. It's called program. Okay. And then here, the name is a field in the database. Okay. And then it has the string as the data type. So on the database level, this is referred to as maybe varchar, maybe text. Okay. But any of them goes here, most likely a varchar. Okay. Now this is an ORM. This is SQL Alchemy. This is what I'm using. I'm using SQL Alchemy for this. This is an ORM. Okay. So same thing. I believe that's clear now. All right. Any other question?
How do we get access to the presentation?
Oh, it's going to be sent to you after this class. Are you in the community, the group on WhatsApp? Hello, can you hear me?
Yes.
We can hear you.
Yeah. It's going to be sent to you. It's going to be sent to the community, the group on WhatsApp. Or it's going to be sent. Any other questions? I don't know if the network has thrown me out.
No,
We can hear you clearly.
Okay. So I guess there are no more questions. And in the absence of any other question, I would hand this off to Imam. We get straight up of class.
All
Imam, over to you.
right. Thank you very, very much, Ezekiel.